Hey everyone, here's our math problem for today. This is taken from the Stanford Math Tournament in 2018, and this is problem number 3. Here's the problem. Given that the roots of the cubic polynomial x cubed minus 7x squared plus 13x minus 7 equals 0 are r, s, and t, compute the value of 1 over r plus 1 over s plus 1 over t. You can pause the video and see if you can solve the Stanford Math Tournament problem. Now let's solve this problem together. There are at least 2 ways of solving this. The first one is using the Vieta's formula. The second one is a combination of synthetic division and quadratic formula. In this video, I'm going to show you these 2 methods of solving this math problem. So let's begin with the first method, the Vieta's formula. So what's the Vieta's formula? If we are given this cubic polynomial ax cubed plus bx squared plus cx plus d, and its roots are r sub 1, r sub 2, and r sub 3, then the sum of the 3 roots is equal to the negative of the coefficient of the x squared term, which is b, over the coefficient of the cubic term, which is a. So you have negative b over a. Now the product of the first and the second roots plus the product of the first and the third roots plus the product of the second and the third roots is equal to the coefficient of the x term divided by the coefficient of the leading term, a. And lastly, the product of the 3 roots, r sub 1 times r sub 2 times r sub 3, is equal to the negative of the constant term d over the coefficient of the leading term, a. This means that if the 3 roots of this cubic polynomial are r, s, and t, then the sum of r plus s plus t is equal to negative b over a, where our b is negative 7 and our a is positive 1. So that becomes the negative of negative 7 over 1, and this is simplified to r plus s plus t equals 7. Let's remember this result. Furthermore, if you take the product of the first and the second roots, the first and the third roots, and the second and the third roots, that is equal to c over a. And our c in the given cubic polynomial is 13, and our a is positive 1. Therefore, rs plus rt plus st is equal to 13 over 1, or simply 13. And let's remember also this result. Finally, if we take the product of r times s times t, which is the product of the 3 roots, that is equal to the negative of the constant term divided by the coefficient of the leading term. So we have here the negative of negative 7 over positive 1, which is equal to 7. Let's remember this result as well. Now our goal here is to compute for the value of 1 over r plus 1 over s plus 1 over t. Let's simplify this first. The LCD of r, s, and t is the product of r times s times t. Now this least common denominator divided by r gives us s times t times 1, that is st. rst again divided by s is equal to rt times 1 is rt, and rst divided by t is rs times 1 is rs. Notice now that this st plus rt plus rs is exactly this part, which is equal to 13. And also this r times s times t is already known to be equal to 7. Therefore, this ratio here is equal to 13 over 7, which is now the value of 1 over r plus 1 over s plus 1 over t, and this is now the final answer, applying the Vieta's formula. Now for the second method, that is using synthetic division and quadratic formula, this is what is going to happen. Make sure that the degree of the terms are in descending order. We have 3, 2, 1, and the 0 degree. Let's get all these coefficients and do not include the variables. So you have 1, negative 7, positive 13, and negative 7. Now from the rational root theorem, if there are rational roots in this cubic polynomial, that rational root is the ratio of the factors of this constant term over the coefficient of the leading term. And one of those possible roots is positive 1. So let's try 1 first if this is really one of the roots. Using now synthetic division, bring down 1. 1 times 1 is equal to 1, and put that here. Then add negative 7 plus 1 is equal to negative 6, and negative 6 times 1 is equal to negative 6. Then add positive 13 plus negative 6 equals 7. 7 times 1 is 7, and negative 7 plus 7 equals 0. So the remainder is 0, and this third row represents a depressed polynomial that is quadratic in form. This means that one of the roots of this cubic polynomial is in the form x minus this value here, which is x minus 1, and the other factor would be this quadratic, which is x squared minus 6x plus 7. This is the constant, this is the x term, and this is the x squared term. And this is equal to 0. So, using now the zero product property, if the product of two factors is 0, then we can equate each of these factors to 0. So we now have two equations, and solving for x in the first equation, we have x equals positive 1. And solving now this quadratic equation, we use the quadratic formula. Here, our b is negative 6, so negative of negative 6 plus or minus the square root of b squared, which is the square of negative 6, minus 4 times the coefficient of x squared, which is 1, and our c is 7, divided by 2 times a, where a is equal to 1. Then simplifying, negative of negative 6 is positive 6. The square of negative 6 is positive 36. 4 times 7 is 28. And the operation is subtraction. 36 minus 28 is equal to 8. So we have 6 plus or minus the square root of 8 over 2. Simplifying the square root of 8, this is equal to 2 square root of 2. All the rest are copied. And then divide each of the terms in the binomial numerator by the monomial denominator. 6 divided by 2 is 3. Copy the plus or minus. 2 divided by 2 is 1. So we have 1 square root of 2, or simply square root of 2. So that means we now have here three roots. One is x equals 1. The other two are 3 plus square root of 2 and 3 minus square root of 2. So these are now the three roots. But this is not yet our final answer. We want to find the value of 1 over r plus 1 over s plus 1 over t. Let's substitute these three results. It doesn't matter whether you call this as r, this is s, or t. The order is not important. So we now substitute these values for r, s, and t, and we simplify. The least common denominator is the quantity 3 plus square root of 2 times the quantity 3 minus square root of 2. So this least common denominator divided by 1 gives us the same LCD, and multiply this by 1. We have the quantity 3 plus square root of 2 times the quantity 3 minus square root of 2. The same LCD again, divided by 3 plus square root of 2. These two will cancel out. What's left is 3 minus square root of 2 times 1, which is 3 minus square root of 2. Then finally, this LCD divided by 3 minus square root of 2, this part here and this part, when divided, will become 1. So what's left is 3 plus square root of 2 times 1, which is 3 plus square root of 2. Then let's continue simplifying this. Notice that you have here a product of the sum and difference of two numbers, and we know that this is equal to the difference of two squares, 3 squared, which is equal to 9, minus the square of the square root of 2, which is 2. So this part here is the simplified form up to here. Then we copy all the rest in the numerator, but the denominator is also the same as this, so you have 9 minus 2. Then simplifying, notice now that minus square root of 2 and plus square root of 2 will cancel each other out. So we now have 9 minus 2, which is 7, plus 3 equals 10, plus 3 equals 13, and the denominator is 9 minus 2 equals 7. And this is now our final answer. Notice that this result is the same as the result when we used the Vieta's formula. So both of these methods resulted to 13 over 7. How about you? Which method do you think is easier for you? If you have any other method, let us know in our comment section. Bye for now.